Let me just press record. Let me wait for it to start recording. Come on. Is it recording? There we go. Okay, so multiplication of polynomials. So whenever I mean multiplication of polynomials, some different things we can do are use the distributive property. So first we're going to look at how to use the distributive property. Let's say we have a problem that looks like this. Like this. Well, to solve this problem, basically we're adding 5x squared times 2x cubed plus x squared minus 3. So we're multiplying those two things together. So in order to multiply these two things together, what we want to do is we want to take 5x squared and we want to distribute it into here, and into here. So we're going to distribute the 5x squared into each of these different parts of this other polynomial. For the purpose of this, I'm going to go ahead and use different colors so that we can kind of see. So I'm going to do this first distribution in blue. So basically what this is telling us to do is to take 5x squared and multiply it by 2x cubed. So that's the first one. Plus, now we're going to do the next distribution. 5x squared times x squared plus, next distribution, 5x squared multiplied by, and we have here a minus 3, so a negative 3. So what we've done is we've taken that 5x squared and we've distributed it to each of these parts, creating different multiplication right here, right? So we have 5x squared times 2x cubed, 5x squared times x cubed, 5x squared times negative 3. Now what we want to go ahead and do is we want to solve for each of these parts. So let me work with this blue one. What you have to do is you want to go ahead and combine like terms. So 5 times 2. Well, 5 times 2 equals 10. Now I have x2 times x3. Whenever we're multiplying two different variables that have different exponents, what we're actually doing is we're adding those. So it becomes x2 plus 3, and that gives me x5. So this becomes 10x to the power of 5. Okay, so basically what we've done here is we've taken our whole numbers, multiplied those by each other, then taking our variables that contain those x's and multiplied by each other. When we multiply those by each other, what we're actually doing is we're adding those exponents. So 2 plus 3 gives me 5. And then I can drop down everything that I have. So I've dropped this down right here, and I've dropped this down right here. And so this is basically the process that we're going to take for each of our different multiplications. So here we have 5. Here we would have kind of an imaginary 1. So 5 times 1, that's 5. X squared times x squared. Again, if you're multiplying exponents, you're really just adding them. So x4, and then drop it down. So 5x4. This next one, we have 5 times negative 3, right? We're putting our whole numbers together. Negative 15. X squared, we have nothing on the other side, so it just stays x squared, right? There's no x on the other side, so x squared equals x squared. And so negative 15x squared. And then now all we have to go ahead and do is add our plus signs. Plus, plus. And so therefore, us distributing gives us this equation right here, which would be the answer for us finding the product of that, those two polynomials added together. Okay. So what you want to do here is you want to use the distributive property. The distributive property gives you different multiplications that you want to go ahead and solve. If you're putting together whole numbers, you're just multiplying them regularly. If you're multiplying variables with exponents, because you're multiplying with exponents, you're going to actually add them, which we saw here. We had 2 plus 3, which is 5, 2 plus 2, which is 4. Here, because we weren't multiplying it by anything, it just equals to itself. And then you just take those parts and you drop them down. So this was dropped down here, this was dropped down here, this was dropped down here, and this was dropped down here. And then you just add in those additions at the end. Okay, so that is how we go ahead and do the distributive property. Using the distributive property makes it a lot easier for us to go ahead and the product or to simplify this expression. And so that's what we ended up here with our solution of finding the property of that multiplication. Okay, questions about how to use the distributive property? So basically, it's called the distributive property because you're taking that variable in the front and distributing it into each of the different parts of this longer polynomial equation. Okay. So let's look at an example of where we might use the distributive property. This says a cereal company offers its product in a variety of sizes, but the dimensions of all their boxes have the same relationship. The length is 4 times the width, and the height is 3 inches greater than the length. Write an expression that represents the volume of the cereal boxes. So luckily here we are given the diagram that contains each of our different dimensions of that cereal box. And we know that volume is going to be equal to length times width times height. That's how we find the volume. And so basically we want to identify our length is going to be 4x. We get that from right here. Our width is going to be x. We get that right there. And then our height is going to be equal to 4x times 3. Right there. So we're just multiplying those together. So 4x times x times 4x plus 3. That is going to go ahead and give us our volume. So we want to go ahead and simplify this so we can find an expression or write an expression that will give us our volume. And so here we want to use the distributive property because we're multiplying all these different parts together. Okay, so the first one we can go ahead and do is we can put this into this. So basically we're having 4x times x. Now I'm going to work with this part first. So 4 times, there's imaginary 1 right here. 4 times 1 is 4. X to the power of 1, there's an imaginary 1 right here, there's an imaginary 1 right here. Times x to the power of 1. Again, if you're multiplying variables with exponents, you're adding them. So that becomes x squared. So this gives me 4x squared. Okay, so what I've done is I've distributed that 4x into that x, and then I've gone ahead and multiplied those different variables together. Oops, I did not mean to do that. No. Okay, well, I'll just go ahead and rewrite it. So we saw that this was equal to 4x squared. Okay, but now we still have, let me change that. Now we still have this other part to work with. So we want to go ahead and further distribute. So I'm going to take this that I just looked for, and I'm going to distribute it into here. And then I'm going to distribute it into this variable. Okay, so that gives me 4x squared times 4x plus 4x squared plus, or times 3, sorry. Times 3. So I've taken what I just found when I distribute 4x times x, which is 4x squared. And now I've taken that product and I've gone ahead and distributed it into my last part. So now I'm here, and so now I can go ahead and solve. Again, you want to group like things. So 4 times 4, those are both whole numbers. 4 times 4 is 16. Again, you have an imaginary 1 right here. So you're looking for x squared times x. Whenever you're multiplying exponents, you're going to add them. So that becomes x2 plus 1 gives me x cubed. So this is going to result in, and I'll write it over here, 16x cubed plus what we're going to look for now. So now I have to look for this blue part. Again, I'm multiplying my whole numbers. 4 times 3, that's 12. Here I only have x cubed. I don't have anything on this side. So it just becomes is equal to x squared. So 12x squared is my resulting, right? I'm just dropping that down. And so that gives me 12x squared. And so therefore, I have this expression, which would represent the relationship, represents the volume of these cereal boxes. So basically, I've used the distributive property to take my original equation, this equation right here, and I've simplified it into this equation right here, which is much easier to work with. Yeah. So when using the distributive property, basically what you're doing is you're taking, and I can go ahead and look at this again, you're taking a part of the equation and you're taking that and you're distributing it into each of the different parts of your other equation. And so that gives you multiple different smaller multiplications to work with. And basically you're just putting together those whole numbers and putting together those exponents and then dropping them down. So that is the distributive property. Is there any questions about how to do the distributive property? Questions? Okay. So now we're going to work with FOIL. I'm sure that you've seen FOIL before, but we're just going to go ahead and go over it. FOIL is another way to go ahead and multiply polynomials together. FOIL basically stands for, and I'll go ahead and write it out here. FOIL stands for, so that we call this the FOIL method. It stands for first, outside or outer, inside or inner, and then last. So that's what FOIL stands for. What it basically means is, let's say I have this expression right here. So this expression is me adding two polynomials together. So I'm multiplying those two polynomials together, right? So I'm multiplying those two equations together. Well, in order to multiply those two equations together, what I can use is the process of FOIL to go ahead and simplify. So basically what you do is you take this first, that's why it's called first, and you distribute it over here. So you distribute it with the other first. So you take that first and distribute it with the other first. And when you distribute it, that becomes A times C. So distributing means we're multiplying. So we're taking A and multiplying it by C. Next thing you want to do is take that first and do it to your furthest outer variable. And so that would give us A times D. Okay. Then you want to take your inner. It's called your inner because it is the inner part. And you're working with these inner two variables. So now we have B times C. So B times C. And then last, you want to do your last. So I basically have distributed to all of my different variables, but I still need to distribute B to my last variable, which is my D. And so by doing this, I've gone ahead and I've FOILed. I basically distributed each of my parts into my other equation. So this would represent my first distribution. This would represent my outer distribution. This would represent my inner distribution. And this would represent my last distribution. And so using the FOIL method tells me that I can use this method to go ahead and simplify this expression. I could simplify it if I actually had variables here. Here I'm just using sample terms, so A, B, C, D. But if I actually had values such as x squared, 5, etc., then I can go ahead and actually simplify. For this, I can't simplify just because I don't actually have variables there. I just wanted to go ahead and show you what the FOIL method was. Okay, Questions about this? So we're going to look at an example. So squaring binomials. So whenever you get a squared binomial, what it's going to look like is like this. And you may have seen this before. It's going to be a binomial, and then it's going to have a square at the top. Whenever you have an expression with a square at the top, what you're going to go ahead and do is basically it's saying that that thing is multiplied by itself 2 times, right? Whenever we have an exponent, we multiply it by itself 2 times. So for example, if I had 2 times 2, 2 squared, I know that's telling me to do 2 times 2. Right? That's what we know about exponents. Exponents tell us to multiply that thing by itself whatever amount of times, whatever amount your exponent is. So basically what this is telling me to do is it's telling me to take this expression and multiply it by itself 2 times. Right? So this would be my first, and this would be my second. So I'm multiplying it by itself. That's what that square means. Okay? So that leaves me with this expression right here. Well, what you may notice is this expression is me multiplying 2 binomials. And what that means is that I can use my FOIL method. Right? So my strategy here is going to be to use the FOIL method. Let me go ahead and copy this over so that we can see this taking place. So we're going to use the FOIL method. So we're going to do first, outer, inner, last, and then simplify. So first, you're taking this first expression, multiplying it by this first expression. So 6x to the power of 4, 6x to the power of 4. Plus, now I'm going to do my outer. So taking this, multiplying it by my outermost expression, that 3. 6x to the power of 4 times 3. Plus, now my inners, so my 2 inner ones, this one and this one. 3 times 6x to the power of 4. Plus, now my last one, 3 with my last, 3 times 3. So now I have these expressions. And like I did with the distributive property, now this gives me a bunch of different multiplications to work with that are much easier. So I want to go ahead and distribute my like terms. So I have 2 whole numbers. So 6 times 6, 6 times 6 is 36. I have x to the power of 4 times x to the power of 4. What we learned is that when we multiply exponents, we actually add them. So that becomes x4 plus 4. 4 plus 4 is 8. So that gives me x8. So now I can go ahead and drop that down. 36 times x8. 8 to the power of 8. Now I'm going to go ahead and move on to my next one, my blue one. Again, I'm combining my whole numbers first. 6 and 3 gives me 18. I don't have an x over here. I only have 1 here. And x4 is equal to x4. So I have 18 x to the power of 4. Okay. And now I'm going to go ahead and work with this green one. I have 2 whole numbers, a 3 and a 6. 3 times 6 is 18. Again, I have x4 on one side, but I have nothing with x on this side, so x4 is equal to x4. I'm not multiplying it by anything, so 18x to the power of 4. So I'm slowly getting my equation, and now I have this last one. I don't see any x's here. I only see whole numbers. So 3 times 3. 3 times 3 equals 9. And so I'm just dropping that down. Plus 9. And so what you see there is I get a expression, which is a simplified expression of the expression that I originally had. So I've taken 6x to the power of 4 plus 3 squared, and I've simplified that to, I can actually simplify this a little further. We'll go ahead and look at how we can do that. So I'm skipping one step. We can simplify this a little bit further because now that we have addition, we know that we can combine like terms. This has an x4, this has an x4, so I can go ahead and add those two together. So whenever I have addition, I'm combining like terms. And so that gives me 36x to the power of 8. I'm combining those two. So the x4 stays, but I'm adding 18 plus 18. 18 plus 18 is 36. And then just dropping down the other side. So this is my simplified expression. And so my simplified expression is 36 x to the power of 8 plus 36 x to the power of 4 plus 9. And the way that I've solved that is I've put out my binomial, so 6x to the power of 4 plus 3 times 6x to the power of 4 times 3. That gives me multiplying two binomials, which means I'm going to use my FOIL method, and then that allows me to break these into smaller multiplications. I just drop down my resulting values, and that gives me my simplified expression. Okay, so that is how you use the FOIL method. By using the FOIL method, basically what you get is you get an expression that, very much like the distributive property, allows you to much easily go ahead and multiply those expressions together. Okay. Questions about this?
No, ma'am.
Okay, perfect. Okay, so whenever we are going ahead and we are multiplying, we can use two things. We can either use the distributive property or we can use the FOIL method. Some are going to be much easier than the others, but basically what you're going to end up with, you're going to end up with expressions that look like this. So they're easier ways to go ahead and break up those multiplications and easier ways to go ahead and solve or to simplify those expressions. Okay, so we learned that the product of the power property and the distributive property for it is the basis of polynomial multiplication. We learned that polynomial multiplication, I'm just going to tell you we didn't learn that. Polynomial multiplication abides by the associative and the commutative property, which we looked at on Tuesday. And basically the product of polynomials is going to be another polynomial. So basically when we're multiplying this, we don't necessarily get a single value. What we get is a more simplified expression, a more simplified polynomial, right? All of these, we didn't get whole number values. We just got more simplified equations. Okay. So we will go over some more example problems tomorrow. But if there's no other questions, you guys may log off and I will see you guys tomorrow. Bye, guys.
Bye, miss.
Bye.